Hello, everybody. Thank you for attending MicroServices Visionaries 2021 by Ortelius. The session topic that I'm going to deal with today is a walkthrough of an application modernization process. I'm going to provide a deep dive into the roadmap of a application modernization journey. I'm Ujwal Yelmareddy. I'm the founder of Interas Labs. It's a Kubernetes engineering company. Have experience of over 15 years in software infrastructure engineering, providing solutions with a focus on high availability, resiliency, scaling, and efficiency. Before we dive in, I want to give a little bit of an introduction about what is a legacy application. A legacy application is an application that is built on previous generation technology. That means that it can be an application that is working, but it has been built on older technology, which is difficult to upgrade, or it may be incompatible with the newer infrastructure, and it is hard to integrate with the latest solutions and services that are out there. And what is application modernization? It is taking this legacy application in and updating that with newer software principles, newer technology like most recent programming languages like Go or newer version of Python, and upgrading the databases and also utilizing the latest infrastructure like cloud or containers. Here are some of the key technologies that are used in an application modernization journey. Most application modernization journeys or initiatives are driven by a motivation to leverage public, private, or hybrid cloud capabilities. Microservices design. It is not a technology, but it is an architectural principle that is used to decouple the services that are part of a monolithic application. Containers. Technologies like Docker are very beneficial when you're using microservices as your architectural pattern because it enables portability, it enables packaging of the application, and allows you to run on any machine that has a container engine on it. Container orchestrators. Container orchestrators like Kubernetes or Nomad provide the ability to scale the containers that are running, to orchestrate the containers and manage the containers when you're running a farm of containers, and to leverage new database technologies. In the last decade, there is a big evolution in databases as well. Like NoSQL is an example where you can store large amounts of unstructured data at higher speeds and retrieve data at faster rate compared to a SQL database, and there are several applications that can leverage NoSQL instead of SQL from a legacy application standpoint, and adopting automation using DevOps principles. So adopting DevOps principles enables faster feedback for developer to gain higher efficiencies in releasing software at a faster speed. So these are some of the key technologies that are used for an application modernization roadmap. So the big question is, why do companies or engineering leaders modernize apps? One of the key drivers for the engineering leaders is to leverage new technology like cloud platforms. Like if an engineering leader wants to leverage cloud and his current legacy application does not support it, he is losing out on a lot of operational efficiency gain that he could bring to the company by not leveraging cloud. So one of the key elements of or the benefits of application modernization journey is to leverage new technology. Leveraging technologies like cloud containers increases the operational efficiency of the developers and the ops engineers and other um, platform management and IT engineering team. Also, to improve reliability, an older software requires new integrations and new upgrades. So when uh, services like cloud is being utilized, there are patterns to increase high availability, to adopt scalability and resiliency, which improves the overall reliability of the application, which is very critical for businesses that are in financial services, healthcare services, e-commerce, and different domains. Increased security. Anytime a software is old, uh, there are a lot of vulnerabilities that it can get exposed to. Leveraging newer technologies allows you to increase the security and adopt new security tools and frameworks that are out there that has more power against any kind of uh, security breaches. Also, business agility. Having de- having a decomposed application to smaller services like microservices um, allows the business to change a single service and make improvements and focus on that service rather than touching the entire big application, uh, and allowing that small change to go into the market creates a lot of benefit for the business and allows it to be agile, creating a big benefit for the business as well as for the customers. Lower cost. Using technologies like serverless technology on the cloud and pay as you go kind of a model services reduces the infrastructure and platform cost by a huge percentage. So allowing those technologies to be leveraged is one of the key benefits as well of an application modernization journey. So overall, the the last but not the least is when an application is being run on the latest infrastructure with high reliability, high security, and higher efficiency, the customer experience is automatically improved. A customer might feel better response times when he is looking up for a report or even browsing through an e-commerce site. When he's able to see that customer experience, it's better for the business. So these are some of the key benefits of modernizing an application. What are some of the few patterns in an application modernization process? Right, so there are several different patterns that are associated with an application modernization journey, but on a high level they can be categorized into three different types. One is lift and shift, replatform, and re-engineer. So what is lift and shift? Lift and shift is an intensive approach, is a less intensive approach where you need to do almost no changes to the application or its code base. It simply moved from an older infrastructure and moved on to a newer infrastructure like a cloud virtual machine from a older machine within a data center, right? So it's simply, as the name suggests, lifting the application as is and upgrading its infrastructure and running it on a newer infrastructure. The second one is replatform. In this approach, there are only minor changes that are done to the application. For example, replacing an older database with a database service that is running on the cloud, or taking an existing application that is running on a server and making few changes and running within a Docker container or a virtual machine to leverage scaling or to leverage higher load balancing capabilities. Those kinds of examples fall under replatforming. And re-engineering. This is the third concept or third pattern. Re-engineering is completely refactoring of the application. It is thinking from ground up how the legacy application could be rewritten from the architectural standpoint or from the code base standpoint. For example, uh, peeling out services from a monolithic application and running them as individual microservices uh, within containers is a re-engineering project, right? Or thinking as an API first design where some of the APIs are serverless APIs running on cloud infrastructure with the front end um, running as well on the cloud. So a complete redesign of the application from the architectural and code standpoint is basically re-engineering, which is very intensive application modernization journey that requires a lot of planning, lot of homework before going into this journey. So now in the next slide, I'm going to walk you through what this re-engineering effort looks like. So here, this is like an 8-week sample application modernization timeline. As you can see, I'll walk through each line item and just give a high level overview of what this slide means in terms of application modernization. As you can see on the projects and tasks column, this timeline is divided into 3 different streams or categories. The first one is a discovery phase. So within a discovery phase, what we are seeing is discovery of a legacy application and its architecture. So in this discovery phase, the team is basically going deep into the legacy application's code base, reviewing the existing architecture, looking at different components of that application, what's the front end looks like, what's the middleware looks like, what are the databases that are being used, and what is the underlying infrastructure that the application is running on, and understanding the application one more time before going into the journey. Then the second phase of the discovery is agreeing on future objectives. In this is a very important aspect of an application modernization journey, on what are the objects that the teams are agreeing on. Like, is this monolithic service now being broken down into microservices? If so, how many microservices are being agreed upon? Is it 3 services, 2 services, 5 services, and what are these services? what are the technologies that will be used to build these microservices, and who will be building these cloud services, like what is the dedicated team for each microservice, and what is the underlying infrastructure that will be used to run these microservices. So agreeing on these objectives will define the outcome of these microservices for the future. So once the discovery phase is done, we have a high level understanding of the applications that are going to be modernized and what are the objectives of that modernization from that standpoint on. Once the discovery phase is done, there are primarily two main streams, which is a development stream and a platform stream. Um, a development team is primarily responsible for developing those microservices or the new services that are decided in the discovery phase, and platform team is responsible for setting up the infrastructure that is required to run the newly built applications as part of the process, right? So even within the development stream, there is a detailed analysis of requirements for each microservice. So each microservice now needs to have a design document in which you would define what are some of the uh, APIs that this microservice would present. What are some of the what would the payload look like? Uh, what are some of the methods that will be going in to these microservices? And each of these microservice will have a design document that will be created. So that is the first step of the development stream. And the second step of the development stream is API development or and testing, right? For example, here I'm taking four services into account: a login service, a payment service, an authentication service, and a rules engine kind of service, right? Uh, each of this service will have its own function, will have a database, or might not have a database, but will have an API that will accept a request and give a response. And each of the service will also have a definition on how the service will be tested once the development is done. So the next stream is platform stream. Within the platform stream, now if you're planning to run this application on a cloud-based infrastructure, the first part of the cloud-based infrastructure setup is networking. You need to set up a base networking uh, framework between your cloud infrastructure and your on-premise infrastructure, or even if you're planning to run just everything within the cloud, you still would require a base network like a virtual network and a VPN connectivity network for your developers to connect over a secure uh, connection to the uh, to your cloud account. Then most of the time when you're running uh, containers, or when you're running microservices, the preferred choice of orchestrating these microservices to talk to each other and to manage the containers that are running these microservices, you need container orchestrators like Kubernetes. So setting up a hardened, well uh, well protected Kubernetes platform is one of the key requirements of a platform setup. Then typically, if you're going with microservices, API gateways is another component that plays an important role, because you do not want to have individual uh, service endpoints, and to manage the authentication and the routing of the calls from the front end to the back end. API gateway plays a major role in being that middleman and gatekeeper for every call that is coming into your backend services that you're going to develop. So setting up API gateway is a very critical aspect as well. If your services are using messaging uh, patterns like Kafka or RabbitMQ, setting up a messaging platform is another critical aspect. So you can leverage patterns like PubSub or any other messaging uh, pattern that you could uh, that you have decided in your discovery phase. Secrets management. A lot of the microservices that you're going to develop will require secrets to be part of the application. Like for example, a database username and password, an API authentication key. These are some of the secrets that are required within your application. But storing these secrets within the code base or within your code repository is a very bad practice, and it causes um, exposure um, to people that are not supposed to see these secrets. So having secret management like HashiCorp Vault or your cloud native secret management services like AWS um, Secret Manager, uh, leveraging these secret management tools will allow you to mask the secrets without being exposed in the code base or in your version control system. Setting up a, a predefined GitOps process to pull the latest versions of your microservices onto your development and and your higher environments like quality assurance environment or performance test environment or production environment is very critical for an application modernization journey. So GitOps is a process in which you are storing all the configurations of the platform in your uh, version control system, and which will act as the source of truth for enabling configuration changes to the platform. And also, whenever a developer makes a change, he makes the change in a final change in the version control system. So propagating that change through the right pipeline and allowing that change to pass through different quality gates needs to be incorporated for the right DevOps practice, uh, and GitOps enables that setup. So having a matured, well thought through GitOps setup is a mandate for enabling application modernization journey. Database setup. So for all the applications that are being developed, if these applications are using databases, having those databases set up with any schemas that are pre are ready is also the responsibility of the platform team to be able to use automation to spin up these databases and to set up backups and recovery systems associated with the databases and set up alarms around databases. So setting up databases is another step for the platform engineering team. Monitoring and alerting. If you're not monitoring, then you don't know what is happening within your system. So there are three kinds of monitoring. One is application performance monitoring, infrastructure monitoring, and your log monitoring, which is also called um, centralized logging setup. So you would want to measure your response times, you want to measure your applications and of your APIs, you want to monitor your CPU utilization of infrastructure, memory utilization of your infrastructure, as well as any degradation of your infrastructure needs to be monitored and alerted. So there are different tools available. Some of the open source tools are Prometheus, Grafana. For logging, there is Elasticsearch, Logstash, and Kibana. Um, a- and there are some other tools like Datadog and Splunk as well that can be leveraged to set up monitoring and alerting. And there is when an application is being monitored, it is important to have the right dashboards in place and right visibility for both DevOps teams as well as development teams to see what is what is happening within the application. So having that set up is is another critical aspect of the journey. Then the actual setup of the production environment where you are going to serve your applications to your customers, right? Um, Typically, all the platform setup that we just talked about needs to be automated. Anything that is automated, you can repeat the exact setup, so that way there is no configuration drift between your development environment and your production environment. So and anytime there is less configuration drift between your non-production environments and production environments, then there is less chances of bugs getting into production. So if you test some software that is exactly similar to your production environment, then you can be confident that the testing is successfully done, right? Obviously, replicating production load and production data will be a continuous challenge, but there are tools and frameworks to overcome those. So a production setup is highly recommended to be a replica of your non-production setup, and that replication can only be done at um, at a faster, efficient way through automation. If you're using cloud, there are several cloud automation, infrastructure automation tools like Terraform or CloudFormation for AWS or Azure templates or for Azure infrastructure. But I personally prefer Terraform, which provides great leverage and providers for individual cloud environments. And it also has several providers for Kubernetes, for Docker, for even Grafana and Prometheus setup. There are different providers that that you can leverage using Terraform. And Terraform also has a great community uh, of engineers who can support with any bugs or issues that you might face. Um, the next part is the system testing. So once you have your application deployed in your production environment, before you expose it to your customers, you want to ensure that you do an end-to-end functional regression and performance tests um, before you launch the application, right? So you have certain level of benchmarks that you can come up either by using the legacy application metrics or by estimating some numbers for a brand new application, and you can set up some benchmarks and reach those benchmarks through these different testing practices that are in place. Once the system testing is done, typically you don't go all out with the application when you're launching it after a modernization process. You typically do a pilot launch. In the pilot launch, you have a subset of customers that are migrated to this new application, and you let them use the modern application that has been developed and gather feedback and do any improvements that are required, and then slowly onboard more and more traffic onto this pilot application. So once uh, as the number of customers increase, you'll make sure that your system is able to handle the traffic, it is able to handle the different scenarios, as well as the load that that is built over over your new modern infrastructure as well as the application. So this is the overall journey of the of an application modernization process. Some of the key things of optimizing this process, which is a little bit of an advanced topic, but I would still want to add few things here. While you are uh, developing these microservices, there are several things that can be done in parallel. As you can see the timeline, like the cloud setup, the cloud networking setup can be done in parallel. The base databases setup, the infrastructure for your microservices like Kubernetes, API gateway, the messaging services like Kafka and secret management, all of these can be set up while your applications are being developed um, by the development teams. So these both um, streams can run in parallel instead of running in a serial waterfall method, and save a lot of time. And the the other important factor, especially in the platform stream, is leveraging automation. So building uh, automation packages, like an automation package for base network setup, an automation package for a Kubernetes deployment, an automation package or a Terraform module for an API gateway setup, Kafka setup, um, setting up GitOps process using tools like Argo CD um, or vworks flux cd, and deploying these applications through automation and storing all this code in a version control system will allow you s- to repeat the same setup for a new project or creating another environment, which is a huge efficiency benefactor. So um, automation is key when you're working with platform engineering. And Testing is another important factor. Having automated tests in place um, for functional testing, having API testing suite in place, um, incorporating the CI/CD to enable testing with for every commit of the developer. Um, these are some of the key factors that needs to be um, thought through to have a highly efficient project plan in place and highly efficient journey, so you can reach your goals in a faster timeline rather than taking months or years to get there with an application modernization journey. That's all I have for you today. If you have any questions or comments, please send them my way. I'll be happy to address them.